Hello guys, we are back with our next lecture. In this lecture, let us go through the next three algorithms for process scheduling. So in this lecture, we will be discussing about, first let us discuss about highest response ratio next guys. Okay, so the response ratio formula is wait time plus W plus S by S guys. So where W is the wait time and S is the burst time guys. So that is the formula. So what we do exactly here is so here concentrate guys. So it's an easy method and very rarely we see a question in GATE guys, and it's, to be clear, it was asked only once. I don't know which year, but it was asked once. I remember. Okay, yes. So we are having three processes, assume in that way, and all of them came at 0th second guys. Okay, so and all of their burst times are 4, 10 and 100. Okay, so assume that we are using the traditional method. So in that case, so let us assume the time quantum as a 1 guys. Okay, yes. So in that case, this first BT will execute for 1 unit of time, right? Yes. So he got 3 units and P1 has been completed 1 unit of time. So how much time did he wait guys? Okay, so or else let us solve in this way guys. So please keep everything aside for now. So 4, 10 and 100, right? Yes. So first what we will do is W plus S by S, right? Yes. So how much time did they wait? So it is the first case, so they did not wait for any time, right? So 0 plus 4 by 4, 0 plus 10 by 10, 0 plus 100 by 100. So all of them got 1, 1, 1, right? Yes. So as that is a clash, so we are going to take the first guy who came. So this is the first guy who came. So we gave P1 for him. P1 slot first. Okay. So once this case is done, so now let us go through the second case. So this is the second case. So now his time is 3 because 1 unit of time he has completed. So 3, 0 plus 3 by 3. And for this guy, it is a 10 only. So 1 plus 10. So he waited for 1 second, right? Yes. So 1 plus 10 by 10, 1 plus 100 by 100. Okay, so it is a 1.1, it is a 1.01. So what we do is always we select the maximum. So among these three, who is maximum guys? So this guy is maximum. So I will be selecting him. We give 1 second for him. Again we will solve the same problem. So 3, 900. So again, how much time did this guy wait? For 1 second. So 1 plus 3 by 3, that is a 1.33. And how much time this guy waited? So 1 plus 9 by 9, which is 1.11. How much this guy waited? 2 plus 100, that 2 plus 100 by 100, that is 1.02. So who is maximum? P1 is maximum. So you will give P1. So in this way you will continue. So this is the concept of response ratio next. So highest response ratio next. So this concept solving is a bit tough guys. So you should calculate until in this way, until all the process has completed execution. So that is the main reason why this question you might not expect in GATE. I think I solved it in some book. So like there will be giving some books, right? Yes. Or in some kind of examination I have solved it. Not in original GATE. I think so, right? Yes. Okay. So I hope everyone got a clear idea, right? Yes. So this is the concept. Okay, so now moving on to the next method, that is a multi-level queue scheduling guys. Okay, so whenever I am discussing this priority or round robin or first come first serve or shortest job first, I was always saying that if this process is having priority, that will be really good. If this process is having round robin concept, that will be really good, right? Because there is no one particular algorithm or one particular approach using which you can say that this is the best thing. You cannot say in that way. So that is the reason why multi-level queue scheduling and multi-level feedback queue scheduling are built guys. Okay, so first let us go through multi-level queue scheduling. So multi-level queue scheduling, what it does is so based on the particular process which we want to do. So assume that our process is a system process like shutting down, or like any kind of, when we press Ctrl Alt Delete, whatever the system might be doing, it is going to show that blue screen with the task manager and all those things, right? Yes. So that is the concept of a system processes. So for these processes, we will use the priority based scheduling guys. Whereas for interactive processes, so interactive processes are like our browser. So you are using browser and you are watching a video. So at that time, these two will be slicing their time and they are working. So they will be using round robin guys. Okay, similarly when it comes to batch processing, like assume that you are editing a video, like it will be done first come first serve, like one after the other, right? Yes. So in this way, so based on their particular properties, we are going to divide. So this is a multi-level queue scheduling. Okay, yes. So based on that particular thing, we are going to push them into the separate thing, and these are permanent guys. So any kind of system process will always go to priority. Very kind of interactive process will go to round robin. Any kind of batch processing, they will go to batch processing, so FCFS, right? Yes. So in this way we are going to schedule. So this is a multi-level queue scheduling. Okay. Moving on to multi-level feedback queue scheduling. Here we are having the same three layers. Here the first layer is having a time quantum 8. So if any particular process, if that process can be done in 8 seconds, it will leave. But what if it is not completed in 8 seconds? You will give one more chance and it will come to this 16 second quantum queue now. So again you will give 16 seconds. So basically if there is any particular process which is under 24 seconds, it will be executed by now, guys. So if it is exactly 24 also, it will come out here. But if it is 25 seconds, it will again join the first come first serve. So basically this is for lengthy processes, right? Yes. So this is the concept of a multi-level feedback queue. So these are all the different 7 algorithms which could be applied on any process scheduling, guys. So like wherever previously I told scheduling, they're all places you can substitute these 7 different approaches, guys. And to be clear, in our systems, we are going to use this multi-level feedback queue or multi-level queue scheduling because these are the best ones, guys. Okay. Yes. And you can never expect a question from this rather than theoretical question, guys. So we will be expecting questions from round robin, first come first serve, first come first serve, right? Yes. So we can expect the questions from first come first serve. So first come first serve is having only non-preemptive version, right? Yes, I'm writing them so that you will be remembering them, right? Yes. And the next type is a shortest job first, which is a non-preemptive. Yes. And the next type is a shortest remaining time first, which is a preemptive. After that we are having a priority, which is of both the preemptive and non-preemptive. Okay. So then we are having after priority what we are having, guys. After priority we are having round robin. Round robin is only of preemptive. Okay. After that we are having this highest response time first or last. Response time next, response ratio next. So that is having the next. So it is based on, I think so it's priority, right? Because it will be changing, right? Not priority, preemptive. Okay. So after that we are having these two concepts which are a mixture of all these things, right? Yes. So now these are all the things and you can expect the questions from this part, guys. There is very rare chance that you can get that from that. Okay. Yes. So now I hope everyone got a clear idea about this process management, right? Yes. So now to be clear, we are done with the process management concept, guys. So this processes we are done and CPU scheduling we are done. So in the next lecture we'll be starting the inter-process communication, guys, and we will be starting that in the next lecture. Okay. Yes. So we'll be starting with process synchronization and all those concepts. Okay. Yes. So I hope everyone got a clear idea with respect to this process scheduling and all those things. So in the next lecture let us start with the synchronization. So let us meet in the next lecture. Thank you. Thanks for watching. Like, share and subscribe for more awesome videos like this. Thank you.